final way we're going to solve quadratics is by using the quadratic formula. You want to use the quadratic formula. It can be used anytime, but it's most useful when your quadratic equation does not factor. You need to memorize this formula. It looks like a lot, but once you get to class, we'll go over something to help you remember it. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So don't forget where a, b, and c come from. They come from our standard form, ax squared plus bx plus c. So your a value is always with the squared, the b value is always with the x, and the c is your constant by itself. Once we plug numbers into that formula, the answer we'll get two answers. They still represent where the graph crosses the x-axis. So for example, we have x squared minus 5x plus 6. And I'm going to solve this by using the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac divided by 2a. So let's identify our a, b, and c right now first. Our a value is always the number in front of x squared. In this case, the number in front of x squared is 1. So my a is 1. My b is in front of x. In front of x, we have a negative 5. And the c value is by itself, so that means it is the positive 6. So we just need to plug in the numbers now. Negative b, so negative stays in front, and then you put in negative 5, plus or minus square root of negative 5 squared, minus 4 times 1 times 6, divided by 2 times 1. Then we just need to clean all of this up. Negative 5 becomes positive 5. Plus or minus. The square root of negative 5 squared is 25. And then I want to do all this multiplication. Negative 4 times 1 is negative 4. Negative 4 times 6 is negative 24. And then 2 times 1 is 2. Keep cleaning it up. On the inside, I can do 2 negatives make a positive, so it becomes 25 plus 24 over 2, which gives me 5 plus or minus the square root of 49 divided by 2. So when we get to this point, we need to separate it into two problems. We need to take this plus or minus sign and separate it. So what we're going to have is 5 plus the square root of 49 divided by 2. Once we simplify that in our calculator, the answer we get will be one of the roots, one of the places that the quadratic crosses the x-axis. Then we also need to do 5 minus the square root of 49 divided by 2. So when I plug 5 plus the square root of 49 divided by 2 in the calculator, you get 6. When you do 5 minus the square root of 49 in the calculator divided by 2, you get negative 1. So that means that the graph crosses the x-axis at 6 and negative 1. Okay, so let's identify our a, b, and c terms first. My a is 10, my b is negative 15, my c is 6. So x equals negative b, so negative 15 plus or minus the square root of b squared. So negative 15 squared minus 4 times a, which is 10, times c, which is 6, divided by 2 times a, 2 times 10. Okay. Negative 15 becomes positive 15. Then I can do negative 15 squared is 225. And then negative 4 times 10 is negative 40. And negative 40 times 6 is negative 240. And then 2 times 10 is 20. Alright, we can simplify this more by reducing the inside. So we'd have 15 plus or minus the square root of 225 minus 240 is negative 15. And leave the 20. Now, you have to think right now. A square root tells me a number times itself that equals that number. There is no number times itself that equals negative 15, because when you take a number times itself, it has to have a positive answer. Like, for example, if I do 7 times 7, that equals positive 49. If I do negative 7 times negative 7, that also equals positive 49. There's nothing I can multiply itself by to get a negative 15. So, at this point, our answer is just finished. We just have to leave it like this. This is why we talked about imaginary numbers in the beginning of the year, because that's where this would pop up. If we were looking at the graph, what that means, based on the graph, is the parabola never touches the x-axis, so it would be above it, and it would be going upwards, and the vertex would be above the x-axis. It would just never touch. Go ahead and pause and do the first you try yourself. So first, let's identify our A, B, and C. Our A would be 1, B would be 6, C would be negative 5. Plug it into our formula, so it would be negative B, or negative 6, plus or minus the square root of 6 squared minus 4 times 1 times negative 5. Times over 2 times 1, which then we need to look to simplify. So 6 squared is 36. Negative 4 times 1 is negative 4. And negative 4 times 5 is positive 20. And then 2 times 1 is 2. To continue simplifying, we can do 36 plus 20 is 56. Divided by 2. Break it into our two separate problems now. We have negative 6 plus square root of 56 divided by 2, and negative 6 minus the square root of 56 divided by 2. So once we plug that into the calculator and simplify, we would get 0.74 and negative 6.74. Go ahead and pause and do the second you try. So our first thing, let's do our A, B, and C. A is 3, B is negative 6, C is 15. So then plug it in. So negative B, so negative 6, plus or minus the square root of B squared, so negative 6 squared, minus 4 times A times C, divided by 2 times A, and then clean it up. Negative 6 here becomes positive 6. So negative 6 squared is 36. Negative 4 times 3 is negative 12. Negative 12 times 15 is negative 180. And keep cleaning it up. We get, if we do negative 36 minus 180, we get negative 144. Divided by 6. Keep cleaning it up. Now, you can't, to find the square root is a number times itself. There's no number times itself that gives you a negative answer. So this is why we talked about imaginary numbers in the beginning of the year. Imaginary number I is equal to the square root of -1. So whenever you have a negative inside of your parentheses, or inside of your square root, you have to take out an I with your answer. So square root of 144 is just 12, and since it's negative, you have to put an I on the outside. Right, that's all we can do with this. We can't combine the 6 and the 12i because they're not like terms. So what this tells me, if you looked at this graph, this parabola would not touch the x-axis at all. It would just be floating up above it somewhere. Right, so if you do the work and you get down to this, to have a negative number inside the square root, you're going to end up with an imaginary answer, which means that your parabola does not touch the x-axis. There are no roots to that problem. That happens sometimes. And so just remember, quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a. You have to memorize that.